today we're going to go over quadratic formula, and specifically with this, we're going to talk about complex numbers. So this is going to be an introduction to complex numbers, which are it's just a fancy way of talking about this imaginary unit that we're now going to be using, and how we can apply them when solving for quadratics and solving the roots. Our goals for today are to be able to factor quadratics, so we're still factoring quadratics. This is never going to go away. It's going to be on here for a long time. And use the quadratic formula to solve quadratics, because we can use this cheat method to be able to solve it, and it'll be sometimes easier, sometimes not. And we want to be able to understand complex numbers and be able to, at least at this point, know what they mean and how to work with them. So just a quick reminder of the quadratic formula. The quadratic formula can solve any quadratic, and it's going to get a little bit ugly. Now, remember that these variables in here just represent the coefficients in front of each variable in our quadratic equations that we're going to be solving. And then you just go ahead and plug and chug. If you want to, you can go ahead and remind yourself of Pop Goes the Weasel. We're going to skip that for now. But another refresher of the quadratic formulas that we can use to solve any quadratic. An example of a quadratic right here, ax squared plus bx plus c is equal to 0. And then what we do is we just go ahead and plug and chug into this formula, replacing every time that we see a b with the number that's in front of the x, every time we see an a with the number that's in front of the x squared, and every time that we see a c with our constant. Now we're going to talk about imaginary numbers. On the side we have a fractal, which is actually created by imaginary numbers, and imaginary numbers get a really bad name. And our basic thing though is we have to ask the question, what is the square root of a negative number? And there's a really long explanation to this. It involves a little bit of calculus and a little bit of algebra. But essentially, we didn't know this for quite some time. In fact, it was Tartaglia who first decided that these might exist, and Descartes also proposed imaginary numbers a little bit later. But this is only in like the 1600s. So think about that. That's only about 500 years ago that this thing actually even started to be considered an idea. And it's the same thing with how our number system has evolved from the Egyptians, where they were the first ones to come up with the idea of fractions. And then we had negative numbers because suddenly we owed somebody something. And then we had to come up with something to deal with with the square roots of negative numbers. So our number system is just evolving to fit the problems that we're encountering. And the basic idea here is that square root of -1 is called I. This is our imaginary unit. By the way, if any of you are considering becoming engineers, it'll end up being J, but for math, we are going to use I. And I'm going to link you in here to a video by Welsh Labs, and it kind of shows you the idea of imaginary numbers. It has this really cool demo that I want you all to see, but I'll link it to you in the description. I'll put a little video link in here too.
Let's say we're
Ignore that. So imaginary numbers, I have Mr. Mime up here because if any of you know Pokemon, he creates this wall that you can't see, and imaginary numbers are just things that you can't see, but they actually exist. And the idea is that whenever you have a square root of a negative, you can factor out a square root of -1, or that imaginary unit I. And let's go through a quick example here of how to do that. We have the square root of -49 is equal to the square root of -1 times 49, because just remember, anytime that we have a negative number, it's just the same thing as saying that we have a -1 times a positive number. And so now we have that square root of -1 in there. We're going to go ahead and factor that out as an I. And so it's equal to I times the square root of 49, or when you get all the way done, it's 7I. This is an imaginary number. It exists, it's real, but it's something that we can't actually understand in our dimension because of the fact of how our universe exists. So we're going to go ahead and solve some of these complex numbers really fast. Let me pull out a calculator. I'm only going to do, these should all be negatives. Whoops. I'm going to do 2 of these really fast because I might skip over this one. I'm just going to skip that one for now. But let's start over here because this one's really nice. This is the same thing as the square root of -1 times 64. Remember, I said I made a mistake, so that should be negative and that should be negative. So now we have square root of negative 1 times 64. Well, this negative 1 is the same thing as I, so we can go ahead and pull that out. We have the I times the square root of 64. Well, it turns out square root of 64 is just 8. Let me make sure that I'm actually doing that right. 8 times 8. Yep, 64. So our answer here is just 8. Or let me rephrase that. We put our number first, 8i. So that is 8i is the same thing as negative root, or the square root of negative 64. This is the imaginary number that goes along with that question that's being asked. Let's do 96. We'll go ahead and factor out 96. So what we're going to do is we have a negative 1 times 96. And if we divide that by 2, we have a 48. If we divide that by 4, which is the same thing as 2 times 2, we will have an 8 over here. No, sorry, we will not have an 8. We'll have a 12. We'll factor that again, so we have a 2 and a 6, and a 2 and a 3. Remember, when we go ahead and factor these things, we're just looking for pairs. So we have one pair there, two pairs there. So in the end, this is why we're skipping the middle one, because the middle one's really big. We have the square root of negative 1 times 2 squared times 2 squared times 2 times 3. And we're going to go ahead and factor out what we can. Well, we can factor out this negative 1, which will be an I. So we have I times 2 squared times 2 squared times 2 times 3. Remember, our square root will undo our squares, so we can pull out both of these 2's out. So we'll end up with 4i times what's left over, and what's left over is the 2 times 6. So we have 4i root 6. This is our imaginary number. And it's weird, it can still be irrational because we have that root 6, it's irrational, and that's completely okay. The idea, though, is that this negative 1 here, I'll circle it right here, our negative 1 right there, our negative 1 right there, it becomes this I, and that's our imaginary part. Go ahead, take a few minutes, and pause this video. Just simplify the square roots using imaginary numbers. Remember, square root of negative 1 is equal to I. That's all you really have to do, and then after that point, you simplify it just like you would a regular old radical.